Let me start sharing my screen. I wanted to start real quick. Before we look at this stuff, I wanted to start real quick and talk about the quadratic quiz that was due by midnight. I was surprised with the first question. A lot of people did it right, but they didn't get the first part right, because when the question asked for the factored form, people were giving me something like x squared plus 5x, and that's not factored. Factored would be the x times the x plus 5. I was looking for the work that it was factored. If I saw that on your work paper, I gave you partial credit for it, but if I didn't see the factored form, you didn't get that partial credit. Another thing that I found concerning was for a couple of people who told me that they didn't know what the square root property is. And what the square root property says is if I have something like x plus 2 quantity squared is equal to negative 49. If I've got a square on one side and a constant on the other, in order to solve that, we're going to take the square root of both sides. And when I have the constant, I have to remember there are two roots, a positive and negative. Doing that here on the square root and the square undo each other. And then another thing that I had concerns with, there weren't a lot, but there were a couple of people who over here told me that this does not exist. But the problem I have with that is if we're just looking at real numbers, it doesn't exist. But this chapter, we expanded our horizons to get those imaginary numbers. Realize that you can have imaginary answers now. And so the answers would be negative 2 plus 7i and negative 2 minus 7i. I think between the two sections, there was somebody who would have put those answers in as 7i minus 2 and minus 7i minus 2. And I didn't see anything in the directions that said it had to be in standard form. And so I accepted that as full credit. The other thing was that one of the questions asked you to solve it using completing the square. And there were a heck of a lot of people who did not complete the square, but rather used the quadratic formula. That question was broken down into two parts. One part asked, what would you add to complete the square? And the other part asked for your solutions. So if you got the right solutions using the quadratic formula, you got half credit, but you really were supposed to solve that one by completing the square. Other than that, does anybody have any questions on the quiz? If there's anybody who did not take it, you need to either send me an email or talk to me after class. If you took it but did not submit your work, I didn't look at it. If you fit into that category, again, either talk to me after class or send me an email. Before we get, go ahead.
I did have a question with that one problem you were talking about where completing the square.
Sure.
When I was doing it, I think my answer was 25 to complete the square. You'd add that to both sides and then solve for the equation. Would I then just subtract 25 for both sides and then do the quadratic?
Now, if you added 25 to both, then you're working too hard and you're undoing everything that you did.
Yeah, that's what I mean. Like, I was confused at that step.
Let's say I had x squared plus 10x plus 3 equals 0. First, I'm sorry, I said 10x and I didn't write the x. You'd get x squared plus 10x equals negative 3. Then I like that you would get to add 25. And so that gives me x squared plus 10x plus 25 equals 22. The reason you complete the square is because now you can write that as x plus 5 squared equals 22. And once you get there, the easiest way to solve that is to use that square root property. So you would get x plus 5 equals plus or minus the square root of 22. And then subtract the 5 to get x equals negative 5 plus the square root of 22 or x equals -5 minus the square root of 22.
Okay.
Does that make sense?
Yeah, because I didn't do the step where I subtracted the constant from the left side and took it to the right side.
You're always supposed to first get the constant alone.
Oh, okay.
And isolate the constant. But again, if you were to the point where you knew to add the 25, the way my labs broke that question down, saying you knew to add 25 gave you half credit. Okay.
Okay. All right.
Great. Anybody else? If not, scooching back up. Homework 1.6, which was on solving the different types of equations, and it ran gamut from fractional equations to square root equations to absolute value equations, is due by the end of the day today. And homework 1.7 will be due by Wednesday. We're going to finish looking at 1.7 today. It deals with inequalities. After we finish those inequalities, that's the end of the chapter. And so we'll finish that new material today. Wednesday, we'll answer any questions that you have. And being that we're done, we'll review. We'll go over everything that we've covered. And we'll also look at, work out a practice test, like a version of the problem test, go through and so you know what to expect. In which case, if we're reviewing on Wednesday, I think some people like to take the test right after the review. And so I'm going to make sure that that test is available for you in my labs from after class time Wednesday, so from like 2 o'clock Wednesday until midnight Saturday. Does everybody see that? Saturday, not Sunday, midnight Saturday. And it'll be available in my labs and you'll have to submit your work in Blackboard. My labs, the only grades that are counting are the homework grades. The quizzes and the tests become graded, get value when they get put into the Blackboard gradebook. Before we get started, any questions on that or any questions on any of the homework problems?
Could you go over question 15 on 1.6?
Sure. Give me a second.
Sure.
Let's see. Gotta go to your class. Gotta go to BAM. Gotta go to my labs. And what question number did you say? Did you say 16?
15.
15, sorry. In my labs, I'm gonna go to course home. In course home, I'm gonna go to, I apologize, I didn't have this open. It's been one of those days where I've kind of been hopscotching from one thing to another. And the preceding section didn't have any homework questions, so I didn't have it open. Do you have it in front of you? Do you know can you?
Yeah, I can pull it up real quick.
Oh, you know what? If you've got to pull it up, then I'll pull it up. It's now working.
I have it.
All right. So do you want, give me a second.
Mm-hmm.
Read me the question.
It's 7x raised to the power of 5 over 2.
Are there parentheses around the 7x or no?
No.
Okay.
Minus 14.
Okay. Equals 0?
Yep.
Okay. When we have a rational exponent, the first thing we want to do is get that term alone. So let's add the 14 to both sides. This gives me 7x to the 5 halves equals 14. And then let me get that all alone. So I'll divide both sides by 7. And that gives me x to the 5 halves equals 2. You ready with me so far?
Yeah.
So now in order to get rid of that exponent, what we're going to do is we're going to raise both sides to the reciprocal power. So we're going to raise both sides to the 2/5 power. On this side, I'll get x. On this side, I'll get 2 to the 2/5, which means I'm taking the 5th root of 2 and squaring it. Or I think that they would probably like it better if you wrote that as the 5th root of 4, squaring first. Did they ask you to express it with rational exponents, or did they ask you to put it in radical form?
It says type an exact answer in simplified form. Use comma to separate answers as needed.
Okay, so that this would be what they'd be looking for.
Okay.
Okay.
All right. Thank you.
Does
I
that
just
make
needed
sense?
the refresher on the fractioned exponents.
Yeah, if you've got a fractional exponents, get that piece alone and then raise both sides to the reciprocal powers. All right. Any other questions? Have I waited long enough? Hearing none, then what's left is solving. Oh, you know what? Let's just make sure that everybody remembers their interval notation. And so let's say I have something that looks like this. How would you write that as an inequality? The smallest value is -2. The largest value is 6. We're saying that x can be in between those two. Because this is square, it can equal the -2. Because this is round, it can't equal the 6. Is everybody comfortable seeing those two as saying equivalent things?
Yeah.
Instead, if I have, let's say, 5 to infinity. This one says the smallest value is 5. There is no largest value, so we're saying that x can be anything greater than 5. And again, because that's an open interval, we're not including the equality. Likewise, if I had the interval from -infinity to, let's say 1, this time there isn't a smallest value, but the largest value is 1. So I'm saying that x is less than 1. Because it's square, it can be equal. Everybody all right?
Just for like a refresher, when you use the infinity, it's always the parentheses, not the bracket, right?
Right, because infinity is a concept, not a number. So we're never going to equal infinity.
Okay.
Infinity will always be open on that side. Okay?
Okay, thank you.
All right. Then if those are all right, I'm hoping that the next couple things that we look at is somewhat familiar territory. We're going to look at the laws of inequality that we're going to use to solve inequalities. The first law that we're going to look at, first rule that we're going to look at is the addition and subtraction property of inequality. And what the addition and subtraction property of inequality says is that you can add or subtract the same quantity to both sides of an inequality, and the direction remains the same. So you can add or subtract the same quantity to both sides of an inequality, and the direction of the inequality remains the same. So what's all that wordiness about? If I were to write that symbolically, I would say that if A is less than B, then A plus C is less than B plus C. If I add the same thing to both sides, my symbol of inequality remains the same. And so when would we make use of that? Let's look at an example. Let's look at x minus 7 is less than 1. If I wanted to solve for x, first I'd want to simplify both sides if I could, which I can't. Then I want to get all of the x's together. I'm trying to isolate the x, isolate the variable. So over here, to get x alone, what would you tell me that you'd need to do?
Add 7 to both sides.
Beautiful, add 7 to both sides. That 7 equals 7, so I'll put an equal sign in between. But when I add down, on the left I get x, on the right I get 8. And because I was adding, that will still say less than. Another equally simple example. If I have x plus 9 is greater than or equal to 17. Nothing to simplify. I want to get the x alone. So this time we'll subtract the 9 from both sides. Then we're going to put an equal sign in between because those two quantities are equal. When I work down, I'm left with x. 17 minus 9 is 8. And because I'm adding or subtracting, that inequality remains the same. I have to apologize. The first one I did not put it into interval form. Interval form, 8 is the largest value. There is no smallest value. And it's not equal on either side. The second one, 8 is the smallest value. We want anything bigger than 8, so there is no largest value. But it's going to be closed at the 8 because it can equal 8. If I add or subtract to an inequality, the direction of the inequality stays the same. Is everybody comfortable with that?
Yep.
If so, then things change a little bit when I look at multiplication and division properties of inequalities. And before we go through and write out what that property says, I'd like to look at some numeric examples. Are we all in agreement that, let's say, -2 is less than +2? Negatives are less than positives. So -2 is less than 2. What happens if I multiply both sides by 3? On the left, I'd have 3 times -2. On the right, I'd have 3 times 2. 3 times -2 is -6. 3 times 2 is 6. And is everybody okay? -6 is less than 6. Negatives are smaller than positives.
Can we like back up for like a second?
Sure.
I don't know if I like missed it or I just didn't hear it. Like why are we multiplying both sides by 3?
Because I made it up. I just picked that number out of a hat. And I just wanted to make sure that the number that I picked out was positive.
Okay.
And I'm doing this to kind of prove a point. So just humor me for a minute, okay?
Okay, thank you.
All right, then let's do that same thing. And this time, let's multiply by -3. On the left, I'd have, whoops, let's try that again. On the left, I'd have -3 times -2. On the right, I have -3 times 2. Negative times negative would be positive. Negative times positive would be negative. Is it still less than? Is +6 smaller than -6?
No.
No, positives are bigger than negatives. And so, yeah, I just made up those numbers on my own. On one, I multiplied both sides by the same positive, and you see how it stayed the same. But instead, if I multiplied both sides by the same negative, because the signs changed, you see that the inequality is reversed. And so that multiplication, and I just made up those numbers on my own. I'm sorry I didn't make it clear that that was what I was doing to start with. To prove a point, you see if we multiply both sides by a positive, it stays the same. If we multiply both sides by a negative, it reverses. And because the rules for sign numbers with division are the same as for multiplication, the same will hold true for both multiplication and division. So with the multiplication and division property of inequality, it's got two parts. First part says, if I multiply or divide both sides by the same positive quantity, the direction stays the same. But if I multiply or divide both sides by the same negative quantity, the direction is reversed. And so if I wanted to write that symbolically, I would say if A is less than B and C positive would be bigger than 0, then AC is less than BC. But if A is less than B and C negative would be less than 0, then AC would be greater than BC. If I multiply or divide by a positive, it stays the same. If I multiply or divide by a negative, it's reversed. Have you folks heard that rule before?
Not in a while.
No. And I hope the silly number problem at the beginning where we multiplied first by +3 and then by -3. In my mind, when I was first given the rule, I'm like, what the heck? But seeing it with numbers multiplying through by a negative, does it help make sense why we've got to reverse it? So, but those are the rules. So now let's look at some examples. Let's solve each. And let's write the solutions in interval notation. So first, let's say we have 2 times parentheses x plus 4, close parentheses, is greater than 3x minus 5. And really solving a inequality is going to be very much first degree inequality. I apologize, we're not going to throw exponents on these. Solving a first degree inequality is very much like solving a first degree equation. The only thing we have to be careful of is if we multiply or divide by a negative, the direction is reversed. So we're going to leave that inequality symbol in there, but we're going to go through the same steps as if it were an equation. So if this were an equation, what would you guys do first?
Distribute.
Distribute. So can we say that we'll simplify first? And the distribution would be our simplification. 2x plus 8 is greater than 3x minus 5. And then, just like with an equation, we want to gather all our variables on one side. We want to get all of our x's together. It's a matter of choice. What would you folks rather move? The 2x or the 3x?
2x.
And how would you do that?
Subtract them both sides.
Beautiful, I like it. I'm going to put that equal sign in between because those are equal. Here I'll get 8. Here I'll get x minus 5. And again, when I add or subtract, that fraction stays the same. Now what would you do? Anybody want to add 5 to both sides? Giving me 13 is greater than x. And again, it stays the same because I was adding or subtracting. So now, is 13 the largest or is 13 the smallest? X has to be smaller than 13, so that's the largest value. There's no smallest value. We can't equal that negative infinity. And there's no symbol of equality, so it'll likewise be open at the 13 side. How's that one for everybody? Ready for the next one? Next one, let's say I have 7 minus 3x is less than negative 2. So now we're trying to get x alone. We can't simplify either side. X is only in one spot. So let's try to get the x term alone first by subtracting 7 from both sides. On the left, I get negative 3x. On the right, I get negative 9. Because I was adding, my inequality stays the same. Now, to isolate the x, we've got to divide by that negative 3. Here I get x. Here I get 3. But because we're dividing by a negative, my inequality is reversed. And so this time I get x is greater than 3. So 3 is the smallest value, and we cannot equal it. So we've got to open on that side. There is no largest value, so we'll go up to infinity. And again, we cannot equal infinity, so it'll be always solved on that side. Open on that side. And again, solving inequalities is very, very, very much like solving equations. You just have to be careful to remember that if you multiply or divide by a negative, you must reverse the inequality. Everybody all right with that? We're going to need to remember that for the next couple types of problems that we're looking at. But if there are no questions, let's go look at that next kind of inequality that we're going to solve. When we look at compound inequalities, to solve a compound inequality, we want to put our solutions in the form A is less than X is less than B, where we isolate the variable in the center. With these, what we're actually doing is we're solving two inequalities at once. By doing the same thing in the same operations, all three parts of the inequality. So what do those look like? We look at a couple of examples. First example we want to solve. We want to express the solution in interval notation. Say I have -8 is less than or equal to 6 minus 2x is less than 12. Again, we said we want to isolate the variable in the center. Because I wrote that underneath, I'm going to rewrite the problem. So just looking at that center part, what's the first thing you folks would do in order to get x alone? Would anybody move the constant, subtract the 6? Does that make sense?
Yes.
But with these, whatever I do to one side, I have to do to all three sides. I'm doing three things at once. We're multitasking. So that gives me -14. That gives me -2x. That gives me 6. And because we were subtracting, my inequalities remain the same. Now, what would you do next to isolate the x to get it all alone?
Divide by -2.
And if I divide any part by -2, I have to divide every part by -2, all three parts. Negative divided by negative is +7. Negative divided by negative is +x. Positive divided by negative is -3. And is everybody all right? Because I divided by a negative, I have to reverse my inequalities. And just for a minute, if I were to pretend that that middle was not there, we'll erase that x for a second. Doesn't it make sense that 7 would have to be bigger than -3? not less than. Just like up here, if that middle weren't there, we'd be saying that -8 is smaller than 12. The big picture has to make sense. Now, -3 is the smallest value, 7 is the largest. I cannot equal -3. My interval is open on that side. I can equal 7, so my interval is closed there. And I know that some students, when they first look at that three-way inequality, they think that there's too much going on. But you notice I'm doing the exact same thing I would to solve an equation. It's just instead of doing it to 2 parts, I'm doing it to 3. Any questions on that one? If not, I'd like to do another example to look at. Let me change the page. This time, I'm going to ask you to solve and express the solution in interval notation. And I'm going to have -6 is less than or equal to 1/2 x minus 4 is less than -3. And I'm going to shut up for a minute and ask you folks to solve that one. Ryan, remind me at the end of class and I'll add you to attendance. Thank you. How is everybody doing? Are you ready to go over, or do you want me to wait a minute?
Can you wait another second?
Sure. Are we ready?
Yeah.
Okay. What did you do first?
I used to,
No, you're good.
Anybody add 4? And again, we have to do all 3 parts, giving me -2 is less than or equal to 1/2 x is less than 1. Now I'm curious, what did you folks do with the coefficient of a half on x? Did anybody remember if you have a fractional coefficient, we're going to multiply by the reciprocal. And again, whatever we do to one, we do to all three. Which leaves me with -4. When I multiply by the reciprocal, I just get 1x. And here I get 2. And so my solution is -2 is less than or equal to x is less than 2. Interval notation. I'm sorry, did I say -4 is less than or equal to x is less than 2? I apologize if I misspoke. -4 is the smallest value. 2 is the largest. We can equal -4, so it's closed on that side. We cannot equal 2, so the interval is open on that side.
I thought you flip the inequality signs if you multiply.
Only if you multiply or divide by a positive. Because that 2 is positive, the direction stays the same. Let me go back for a minute. Remember when we were looking at numbers, we had this inequality, and when we multiplied by 3, they stayed the same. It was only when we multiplied by the -3 that it changed. So it only changes if you multiply or divide by a negative. If it's
Okay,
positive, they stay the same. Okay?
Thank you.
Can I give you like a silly little kid way of seeing if you did it right or not? Silly little kid way. I'm not going to put any of that middle in. Silly little kid way. Were you all right that this is -4 and that this is +2? Is -4 smaller than 2 or larger than 2? It's smaller. And so to keep that relationship, it has to stay the same. Does that make sense?
Yes.
Okay, great. When I solve a three-way inequality, I always kind of, for a minute, if we were on campus, I would put my thumb over that X in the middle, and I try to make sure that I realize that -4 is indeed less than or equal to 2, and not the other way around. So if we're okay with these compound inequalities, there's a reason we need to do them. We need to use them in order to be able to solve absolute value inequalities. And before we look at absolute value inequalities, or actually while we look at absolute value inequalities, we have to consider 2 cases. For the first case, let's look at an example. Let's say I know that the absolute value of x has to be less than 3. If I tried to list the integers that are in the solution set, absolute value of x is less than 3. Could x equal 3? I don't think so. We get 3 is less than 3. Is everybody all right? X could equal 2. The absolute value of 2 is smaller than 3. It could equal 1, right? The absolute value of 1 is smaller than 3. It could equal 0. The absolute value of 0 is less than 3. Could I add some negatives? Is the absolute value of -1 less than 3? Yep, that one works. Could I add -2? Is the absolute value of -2 less than 3? Yep, that would give me 2 is less than 3, so it works. Could I add -3? Is the absolute value of -3 less than 3? Oh, that says 3 is less than 3, so it doesn't work. And so looking at the integers that worked, does it make sense that if the absolute value is less than a number, what I'm taking the absolute value of here would have to be in between -3 and 3. And so first case, to solve, the absolute value of x is less than some value a, then I know that -a is less than x is less than a, and I have to solve the compound inequality. Does that make sense? I guess we could also look at it. Let me do this up above here. We could also look at it if the absolute value of x is less than 3, that means I'm within 3 of 0, and it could be on either side. Instead, if I said the absolute value of x has to be greater than 3, and I wanted to list the integers, for the absolute value to be bigger than 3, I could have 4, I could have 5, I could have 6, and I could keep going. Again, this time I'm looking for numbers that are further from 0 than 3. And so it would be anything further away from 0 than 3. But wouldn't there also be values on the other side? Wouldn't -4 work, -5 work, -6 work? And so if the absolute value of x is greater than 3, we'd say that x is greater than 3, or x is less than -3. So to solve that the absolute value of x is greater than a, then we solve x can be greater than a, or x can be less than -a. I have to solve 2 inequalities and take their union. Does that make sense? Either way, to solve an absolute value inequality, the first thing that we need to do is isolate the absolute value And then if the absolute value is less than some quantity, we have to solve the compound inequality. Negative a is less than x is less than a. Or if the absolute value is greater than a quantity, we have to solve the two inequalities. And take the union. So we get that x can be greater than a, or x can be less than negative a. So shall we try some examples?
Yes.
Let's say I have the absolute value of 2x plus 6 over 3 is less than 2. My absolute value is all alone. Because it's less than, I'm going to change that to a compound inequality. Negative 2 is less than 2x plus 6 over 3 is less than 2. And again, I'm going to cover up that middle for a minute. So just for a second, I'm going to erase that middle. And see, is it true? Is negative 2 smaller than 2? Yep, so I know I'm doing okay. To solve that, then we multiply each part by 3, giving negative 6 is less than 2x plus 6 is less than 6. To get the x alone, would everybody subtract 6? Leaving me with 2x in the middle. And if I subtract 6 from any part, I have to from all 3 parts. Now to get x all alone, I have to divide by 2. I have to do it to all 3 parts. Gives me negative 6, x, and 0. Because that 2 is positive, it stays the same direction. And double checking. If I pretend the x is not there, negative 6 is less than 0. So I did something right. Smallest value is negative 6. Largest value is 0. And there's no equality, so it's an open interval. Is everybody all right with that one? Can we try another? What if I have 4 plus the absolute value of 3 minus x over 3 is greater than or equal to 9? With this one, the absolute value is not alone yet. First thing we want to do is isolate that absolute value. So I'm going to subtract the 4 from both sides, giving me the absolute value of 3 minus x over 3 is greater than or equal to 5. Now we're saying it's further from 0 from 5. It's greater than. So I have 3 minus x over 3 is greater than or equal to 5. Or 3 minus x over 3 is less than or equal to negative 5. From here, would everybody subtract 3 from both sides? Because we're subtracting, the inequality remains the same. And then to get x alone, we'd multiply both sides by -3. Negative times negative is positive. Positive times negative is negative. Because we multiplied by a negative, we reverse the inequality. And that was so much fun. We get to do the same type of work again. On the other side, we'll subtract 3 from both sides, getting negative x over 3 is less than or equal to -8. And now when we multiply by -3, we get x. Because it's a negative, I have to change the direction, is greater than or equal to 24. Interval notation. -6 is the largest on this side, and I'm keeping going smaller, so I'll go -infinity. And I'm sorry, that should be closed at -6. On this side, 24 is the smallest, and I keep getting larger. I'm going to infinity, and I'm going to take the union, so that this would be my final answer. I'm getting silence. Is that okay or not?
Can you do another one like that?
What I was going to do was I was going to put 2 more up and actually ask you folks to try to solve them on your own. -3 times the absolute value of x plus 7 is greater than or equal to -27. And then the other one is 3 times the absolute value of x. Oh, I'm sorry, I miswrote it. X minus 1 plus 2 is greater than or equal to 8. Did you folks want to try these on your own, or did you want to go over them together? Nobody's answering me.
Can we try though?
Sure, I'm going to be quiet for a minute then.
All right.
I'm going to have a coffee break. And this is the one time where I wish I were in a classroom and I could walk in between you guys and look over your shoulders. Are we ready for the first one or not yet?
I got stuck at the first one, so I'm ready for you to go over it.
Okay. Remember we said we want to get the absolute value all alone first, right? As I look at this side, you see how the absolute value isn't all alone? It's being multiplied by -3. So with this one, I divide by the -3 first. With me so far?
Yes.
So that gives me that the absolute value of x plus 7. Over here, when I divide, I get 9. But remember, when you divide by a negative, you flip it. And when we're saying that the absolute value is less than, that's when we can turn it into that compound inequality. I can string them all together because if I get rid of the middle, I'm saying that the negative is smaller than the positive. So it makes sense. Now to get x alone, we'll subtract 7. That would give me x alone in the middle. And again, whatever I do to one of the three, I have to do to all of the three. That gives me x. -9 minus -7 is -16. 9 minus 7 is 2. And when we subtract, it stays the same. But again, I'm like a little kid, so I want to double check. Yep, -16 is smaller than 2, so it works. And it would give me the interval below. Any better?
Yes. I don't know why I wanted to subtract before I divided. So
No.
that's what threw me off.
You always want to get what's inside the bars alone. You always want to get the bars alone first. The absolute
Okay.
value, okay?
Yes.
Not until it's all alone that we decide whether we can do a compound inequality or two separate. So if I look at this next one, the absolute value bars are definitely not all alone. With this one, to get the bars alone, what would you do first? Divide by 3 or subtract the 2?
Subtract the 2.
Beautiful. So that gives me 3 times the absolute value of x minus 1 is greater than or equal to 6. Now the bars are still not alone. So now I'm going to divide by that 3. Gives me the absolute value is greater than or equal to 2. And so I'm going to have x minus 1 is greater than or equal to 2. Now, if I try to sandwich it, I just put the -2 over here. You see, that would not make any sense whatsoever because -2 is not bigger than +2. And so that's when I know, okay, then I have to do that the x minus 1 is less than or equal to -2. Solving on the right, I'll add 1 to both sides. And I'll get x is less than or equal to -1, which gives me the interval from -∞ to -1. On the left, adding 1 will give me x is greater than or equal to 3, giving this interval. And when I see that word or in the middle, I know I need to take the union. That one any better?
On one of the homeworks, we had to solve problems like where we find what the union is. Do you want the answer like that, or do you want it like with the union sign stuff?
When you're taking the union of two intervals, I think we had talked about this last class, but let's go ahead and let's look at some. Let's say I have negative open interval from -3 to 5, union the interval from 1 to 7. When I look at the union or the intersection, what I'm going to do is I'm going to draw each of them separately. -3 to 5. That means I'm going from -3 to +5, not including either, everything in between. Next one, 1 to 7. I'm going from 1 to 7, and I'm including everything in between. And when I take the union, I'm putting those together. I'm combining them into a single one. So when I combine those, the smallest would be -3. The largest would be 7. I'm not equaling -3. I am equaling 7, and I want everything in the middle. So this one, -3, 5, union 1, 7 would be equal to, it would be open at -3, closed at 7, because I'm just putting them together.
Yeah, so is that how you want the answer, or do you want the
That's how
answer?
this would be the answer for this one. But if I had another one that said, let's say, -2 to 2, union 4 to 9, and I look at this one, and the first one is from -2 to 2, and the second one is from 4 to 9. When I put them together, there's no overlap, right? When I put them together on one number line, I've got these two disjoint pieces. They have nothing in common. And so this one, the final answer would just be -2 to 2, union 4 to 9. I can't condense it at all. Do you see the difference between this example and this example?
Yeah, thank you.
And so I know you want a blanket answer. If there's a union, you can just leave it as is. But it depends. When you put the two together, if you just get one single interval, only write the one single interval. But when you put the two together, if they don't overlap, you've got to write them separately with the union sign in between. So I guess my answer to the question you were asking is, it depends.
Okay, thank you.
All right, and that was a very good question, and I'm sorry. I know life is always easier if it was always one way or the other, but do you see how with these two examples, you could get two different possibilities?
Yeah.
Okay. Anything else? If not, please stick around for a minute. I want to stop sharing. In the other class, the other section, I got a little annoyed with the number of people who disappeared long before class was over. And so I ended up taking attendance again after class. It took care of the people who showed up late, if they were still there. And it I'm giving an extra credit quiz to the people who are still answering me when I talk to them right now. If you're here, you get a 5 out of 5. If you're not, you get a 0 out of 5. So hopefully it's worth your while. I'm going to just go across the screen. Hannah, are you still here?
Yeah.
Great, you've got it. Michael, are you still here?
Yep.
You've got it. Mary, are you still here?
Yes.
You've got 5 out of 5. Lauren, are you still here?
Yes, I'm here.
Great. Mo, are you still here?
Yeah, I'm here.
Olivia Moran, are you still here?
Yes.
Beautiful. Brad, are you still here?
Yes.
Great. Charles, are you still here?
Yeah, I'm here.
Great. Morgan, are you still here?
Yeah, I'm here.
Beautiful. Kayla, are you still here?
I'm here.
Great. Dale, are you still here?
I'm here. Sorry I don't answer your questions. My house gets really loud and I don't want my audio to mess with the class.
You know what? If you're fine with it, I'm okay with it. If you have a question, though, I would love to hear your background noise rather than have you go out and leave the class with an unanswered question. Okay?
Okay.
Elise, are you still here?
Yep, I'm here.
Good. Olivia Smith?
I'm here.
Great. John, are you here?
I'm here. I'm here.
Beautiful. Alyssa, are you here?
I'm here.
Beautiful. Eviente, are you still here?
Here.
Beautiful. Stephen, are you still here?
Yep, I'm here.
And Miguel, are you still here?
Yes, ma'am.
All right. Hey, you guys are awesome. Everybody was still here. The other class, when I did that, by the time I ended class, the other section, I only hit a quarter of the people there. And of the quarter of the people who were there, 3 of them were no longer around. It was just kind of like an empty box with nobody there. So thank you for sticking around to the end of class. Did you learn something? Was it worth your while being here?
Absolutely.
Okay,
Yes.
good.
Did you
Any,
get
any questions on anything we did?
I'm good.
Okay, great. Have a great day. And again, you just, by being here, you got a 5 out of 5 on an extra quiz.
Woo.
Thank you.
Oh,
Yeah.
well, no, thank you for caring enough to still be here. You made my day, guys.
I actually have a question for you.
Okay, again.
It's just I know I
Sure,
I
stop
forgot to remind
recording
you, so
first.
it's my fault. But that quiz you